Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0976, indicates a problem in the shift solenoid valve BS circuit of the Honda Civic models from 2011 to 2015. This issue is specifically related to electrical circuit failures and does not stem from mechanical problems within the transmission system. The shift solenoid valve B is crucial for regulating fluid flow within the transmission, controlling gear shifts, and ensuring smooth operation. Located within the transmission assembly, the valve receives signals from the powertrain control module, PCM, to manage its duties. Understanding this code is essential for proper diagnosis and repair, since it allows the technician to focus on electrical issues rather than mechanical disturbances. This initial identification sets the stage for a detailed troubleshooting process aimed at resolving the DTC effectively, ensuring the transmission operates optimally once repaired. The DTC P0976 is triggered by an issue within the shift solenoid valve B circuit, affecting the vehicle's shifting performance. This solenoid is vital for managing the hydraulic pressure that influences gear shifts in automatic transmissions. The role of the shift solenoid is to direct transmission fluid flow based on commands from the PCM, which interprets driving conditions and driver inputs. Located inside the transmission assembly, failure in this subcomponent can lead to delayed or harsh shifting, impacting overall vehicle performance. Given that the P0976 code points to electrical issues, it is essential to focus on the solenoid wiring and connections, rather than the mechanical aspects of the transmission. Understanding the solenoid's function aids in determining specific points of failure during troubleshooting. The primary cause of DTC P0976 is an electrical circuit malfunction, which indicates a breakdown in communication or an open circuit that interferes with proper solenoid operation. A failed shift solenoid valve B is another potential cause. This could occur due to internal wear or damage that affects its ability to function correctly. Additionally, issues such as a blown fuse in the circuit can lead to this trouble code. The specified fuse for this solenoid is fuse number B715A, located in the underdash fuse relay box and must be inspected. Understanding these potential causes guides technicians in isolating issues and determining the necessary steps for repair. Each aspect must be assessed to pinpoint the root issue effectively. Drivers may notice several symptoms when DTC P0976 is present. A common symptom is harsh or erratic shifting, where the vehicle shifts gears abruptly rather than smoothly. Additionally, there may be a delay in gear engagement, which can cause hesitation during acceleration. Such symptoms can directly impact driving comfort and vehicle performance. The check engine light will likely illuminate on the dashboard, alerting the driver to an issue that requires attention. A lack of awareness regarding these symptoms can lead to further transmission damage if not addressed promptly. Recognizing these signs is crucial for ensuring timely repairs and maintaining vehicle functionality. To commence troubleshooting for DTC P0976, the first step is to turn the ignition switch to the on position without starting the engine, or by pressing the engine start-stop button. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs. Following this, start the engine and allow it to warm up to its normal operating temperature. This is indicated by the radiator fan activating twice. It is essential for the engine to reach this temperature to ensure accurate testing conditions. During this warm-up period, monitoring the vehicle's behavior is vital. After the warm-up, the vehicle must be test-driven in drive at speeds of 37 miles per hour, 60 kilometers per hour for at least 10 seconds. Finally, after the test drive, Check for any pending or confirmed DTCs with the HDS to determine if P0976 is indicated. If it is, this confirms that the failure has been duplicated, and troubleshooting can proceed to the next step. In this step, begin by turning the ignition switch to the lock position or selecting off mode on the engine's start-stop button. It's important to ensure that the vehicle is fully powered down before checking any fuses. The specific fuse to check is fuse number B7, which is rated at 15 amps. This fuse is located within the under-dash fuse/relay box, which is typically found near the driver's footwell area. Inspect the fuse to determine if it is intact or if it is blown. If the fuse is okay, then the troubleshooting process can proceed to the next step. However, if the fuse is blown, it must be replaced with a new 15-amp fuse. Should the new fuse blow again, this indicates a short to ground on the circuit associated with the B7 fuse, requiring further inspection and repair of the wiring in that circuit. For step 3, begin by jumping the SCS service check signal line using the HDS. This action allows for proper diagnostic testing and aids in isolating electrical issues. Next, disconnect the PCM Powertrain Control Module Connector A, which is a 51-pin connector, as specified in the diagnostic text. Once this connector is removed, turn the ignition switch to the on position again. With the ignition on and the PCM connector A disconnected, measure the voltage between two designated points. Specifically, test the voltage between test point 1, which is the number 1 terminal blue wire on PCM connector A, and test point 2, which is body ground. This voltage measurement must be taken under the condition of IG on or on mode. If there is battery voltage present, the IG1 mis-sol wire is confirmed operational, allowing the technician to move to the 4th step. If battery voltage is not present, it indicates an open in the IG1 mis-sol wire that requires repair. Step 4 involves testing the functionality of the shift solenoid valve B. There are specific procedures to undertake for testing to determine if the solenoid operates correctly. This test will determine if the underlying problem lies within the solenoid itself or in the circuits leading to it. If the shift solenoid valve B is confirmed to work properly, the technician is directed to move on to the next troubleshooting step. Conversely, if the solenoid does not work, it will require further investigation into the cause of its failure, which may involve, etc. Moments like these highlight the need for thorough checks to prevent overlooking potential issues affecting vehicle transmission performance. Correctly identifying whether the solenoid itself is to blame is crucial in honing in on the root cause of the DTC. Continuing with troubleshooting, Step 5 requires the technician to turn the ignition switch to lock or off before proceeding. After ensuring power is off, jump the SCS line once again with the HDS for testing purposes. Disconnect the solenoid wire harness 8P connector from the engine wire harness side, as well as the PCM connector B, 51P. With these connectors disconnected, check for continuity between the specified test points. The test points include number 4, green-white wire from the solenoid wire harness 8P connector and body ground under the condition where the ignition is off. This test conditions help reveal short circuits within the Sol B wire. If continuity is confirmed in this line, it indicates there is a short to ground present between the solenoid wire harness and the PCM, which must be repaired. If continuity is absent, then the switching circuit itself is intact, prompting the technician to check whether the PCM needs an update or if a known good PCM needs to be substituted. The final troubleshooting step requires removing the solenoid wire harness to measure the resistance of the shift solenoid valve B. Once the harness is disconnected, the resistance between the designated terminals of the solenoid must be measured according to the specifications laid out in the diagnostic text. It is vital that the reading falls between 8.9 and 12.2 ohms for the solenoid to be deemed operable. If the resistance falls within this range, it confirms that the shift solenoid valve B is functioning correctly. As a result, the solenoid wire harness would need replacement if other faults are identified in the wiring. On the contrary, if the resistance is not within the specified range, this indicates that the solenoid valve is defective and requires replacement of the entire valve body. This step is critical for restoring the correct operation of the transmission and should not be overlooked in the troubleshooting process. After completing all necessary repairs related to DTC P0976, it is imperative to verify that the repair was successful. Begin this verification process by using the HDS to clear the DTC codes from the system. This action resets the vehicle's diagnostic parameters, allowing for a fresh assessment of the transmission system. Next, it is crucial to conduct a test drive under similar conditions in which the DTC was originally triggered to ensure everything operates correctly this time. Throughout the test drive, pay attention to the vehicle's shifting performance to confirm it operates smoothly without ill effects. Finally, after driving the vehicle, check again for any recurrences of DTC P0976 using the HDS. If the code does not reappear, it indicates that the repairs have been successfully completed, restoring proper functionality to the shift solenoid circuit. To ensure long-term reliability and performance, it is essential to implement preventive maintenance measures concerning the shift solenoid valve and associated systems. Regular inspections of the transmission fluid quality and levels can help identify potential issues before they develop into serious problems. Keeping an eye on the electrical connections and wiring inspects for any signs of wear, corrosion, or degradation that could lead to circuit failures. Additionally, updating the Powertrain Control Module (PCM) software when new versions are released from Honda can improve vehicle performance and address known issues. Establishing and adhering to a regular maintenance schedule can significantly reduce the risk of triggering DTCs like P0976 in the future and enhance vehicle lifespan. In conclusion, understanding and addressing DTC P0976 involves diagnosing specific electrical issues within the shift solenoid valve B circuit. This diagnostic process begins with verifying the ignition state and checking for pending codes using the HDS. Throughout the troubleshooting steps, various components, including fuses, connectors, and the solenoid itself, must be inspected to identify the root cause of the code. Proper execution of each step is crucial to ensure the repair is effective, ultimately leading to a resolution of the shifting problems experienced by the driver. Additionally, establishing a routine for preventive maintenance can mitigate future risks of sensor and circuit failures, keeping the vehicle performing efficiently. Effective diagnosis, informed repair, and diligent maintenance are key to maintaining the reliability of the Honda Civic transmission system. Please like and subscribe to the channel. See you next time!